Today, we will learn about ratio. This is Rahul, and she is his sister, Meena. Rahul's age is 4 years, while Meena's age is 1 year. If we have to compare their ages, then how are we going to do this? Think for a while. Let me tell you, in order to compare their ages, we can say that Rahul is elder to Meena. This kind of statement tells us about the quantity being greater or smaller, but it cannot give us a clear idea about how many years is Rahul elder to Meena. If we subtract their ages, then we get 3. This shows that the difference between their ages is 3 years. Therefore, we can say that Rahul is 3 years older to Meena. This method of comparison is called as comparing quantities by subtraction. If we keep thinking, we can also compare their ages using another method. Think what it would be. Let me tell you. If we divide Rahul's age by Meena's age, then we get 4 as the result. This shows that Rahul's age is 4 times the age of Meena. Here, we have compared two quantities based on how many times is one quantity of the other quantity. The method in which we compare two quantities in terms of how many times is known as the comparison by division. In this example, year is used as the unit of age. We can say that the units of both the quantities are same. When units of two quantities are the same, then the comparison by division is known as ratio. Therefore, Rahul's age to Meena's age using the comparison by division is a ratio which is represented by 4:1. Similarly, we can say that the ratio of Meena's age to Rahul's age is 1:4. We denote ratio by the symbol colon to compare two quantities. Now consider this case. If we represent Rahul's age in months, that is 4 into 12, which is equal to 48 instead of 4 years, and Meena's age is represented as 1 year, then will it be correct to write the ratio of Rahul's age to Meena's age as 48:1? Think for a while. You are absolutely correct. This will result in incorrect ratio because this ratio is showing that Rahul's age is 48 times that of Meena's age. But from the given ages, it is clear that Rahul's age is 4 times that of Meena's age. Thus, 48:1 is not the correct ratio. In order to get the correct ratio, it is necessary to keep the units of the quantities the same. Otherwise, it will result in an incorrect ratio. To convert the quantities into same units, we can divide 48 months by 12 and convert it into years. Here, 48 months is equal to 4 years. Thus, we can write the ratio of ages as 4:1. Similarly, we can also get the ratio of their ages by converting the units into months. If we keep Rahul's age in months and express Meena's age too in months, then we get both their ages in the same unit. Since the units are the same, we can find the ratio of Rahul's age to Meena's age as 48:12. Now, you must have a question that when we kept the units in years and found the ratio of their ages, the result is 4:1. But when the units are kept in months, we got a ratio of 48:12. Are both these ratios equal? Think for a while. Let me tell you, for your information, we can represent any ratio in the form of fraction and any fraction in the form of ratio. Therefore, we can write 48:12 as 48/12. You already know that we can get equivalent ratio by multiplying or dividing the numerator and denominator by the same number. Since the HCF of 48 and 12 is 12, we divide both the numerator and the denominator by 12. By doing so, we get its equivalent fraction as 4/1. We can write this in the ratio form as 4:1. Thus, we can say that 4:1 is equal to 48:12. If two ratios are equal, then we can say that they are equivalent ratios. Like 4:1 is equal to 4 by 1, which is equal to 4 into 2 by 1 into 2, which is equal to 8 by 2, which is equal to 8:2. Similarly, 48:12 is equal to 48 by 12, which is equal to 48 divided by 2 by 12 divided by 2, which is equal to 24 by 6, which is equal to 24:6. Till now, we have represented all the ratios without units. Can you tell the reason behind this? Think about it. Let me tell you. We can write ratio of Rahul's age to Meena's age as 4 years is to 1 year. It can be represented in fractions as 4 years by 1 year. If we observe this, you will see that the units in numerator and denominator are common. Therefore, we can cancel them. We get the fraction 4 by 1, which is without units. It can be represented in ratio as 4:1. That is why there are no units for any ratio. Now you must have understood the concept of ratio very well. Today, we have learned about ratio. In the next video, we will learn it better with some examples. Today, we will see some examples of ratio. Rahul purchased 2 chocolates and 3 pens from a shop. Here, we can say that the ratio of number of chocolates to the number of pens is 2:3. Can you tell some more situations where ratio would be 2:3? There are many situations which have ratio 2:3. Let us discuss them. If 2 cups of flour and 3 cups of milk is used to make a cake, then we can say that the ratio of flour to milk in the cake is 2:3. Do you know that the ratio of breadth to length of the Indian flag is also 2:3? If there are 24 girls and 36 boys in a class, then the ratio of girls to boys is 24:36. Upon dividing its numerator and denominator by 12, we will get the equivalent ratio of 24:36 as 2:3. If a shopkeeper sells wheat at the rate of 26 rupees per kg and rice at the rate of 39 rupees per kg, then the ratio of the cost of wheat to the cost of rice is 26:39. Upon dividing the numerator and denominator by 13, we get the ratio 2:3. Think of some more similar situations in your daily life. Next example. Puneet sells 150 newspapers daily, out of which some are Hindi and some are English. If the ratio of Hindi newspapers to English newspapers is 2:1, then find out how many Hindi and English newspapers Puneet sells. From the given example, we can say that out of 150 newspapers, the ratio of Hindi to English newspapers is 2:1. Can you tell what this ratio represents? Think about it. Let me tell you, this ratio represents that Hindi newspapers are 2 times of English newspapers. That means if we divide 150 newspapers into 3 equal parts, then 1 part will represent English newspapers and 2 parts will represent Hindi newspapers. Therefore, the number of Hindi newspapers will be 2 by 3 parts of 150 newspapers. Thus, the result will be 100. Similarly, the number of English newspapers will be 1/3 part of 150 newspapers. Thus, the result will be 50. Therefore, the number of Hindi newspapers out of 150 is 100 and the number of English newspapers is 50. Next example. A person takes 2 hours to cover a distance from his village to the city. But if he takes the bus, then he reaches in 30 minutes. Find the ratio of the time taken to cover the distance by walk to the time taken by bus. In order to find the ratio between the time taken by the person by walk, that is 2 hours, to the time taken by the bus, that is 30 minutes, we first need to make the units the same. Since 1 hour is equal to 60 minutes, 2 hours is equal to 120 minutes. The ratio of time taken in covering the distance by walk to the time taken in covering the distance by bus is 120 is to 30. Usually, we represent this ratio in its simplest form. We write 120 is to 30 as 120 by 30. Since HCF of 120 and 30 is 30, we will divide the numerator, that is 120, and the denominator, that is 30, by 30. So, we get the simplest form as 4 by 1. This can be expressed as 4 is to 1. Therefore, the ratio of time taken by the person to cover the distance by walk to the time taken by bus is 4 is to 1. Today, we have seen some examples of ratio. In the next video, we will see some misconceptions related to ratio. Today, we will see some misconceptions and common mistakes related to ratio. Misconception 1. The monthly income of Dinesh is Rs 12,000. He saves Rs 5,000 per month. Find the ratio of his savings to expenditure. Some students don't understand the question properly. Ignoring what was asked in the question, they simply represent the given numbers in the ratio form. This way, they choose option 1 as the answer, which is incorrect. Here, we have to find the ratio of savings to expenditure. If we deduct his savings from the income, then we can find the expenditure of Dinesh. Thus, expenditure is equal to Rs 12,000 minus Rs 5,000, which is equal to Rs 7,000. We have to find the ratio of savings to expenditure. Here, savings is Rs 5,000 and expenditure is Rs 7,000. Thus, the ratio of savings to expenditure is 5,000 is to 7,000. Therefore, the correct answer to the given question is option 3. Some students think that the ratio can be represented in any order. Therefore, they represent the ratio of savings to expenditure as 7,000 is to 5,000. But this is incorrect. Hence, option 2 is an incorrect answer. The ratio should be represented in the same order as asked in the question. Misconception 2. Anita has some lace. Its length is 6 meter and breadth is 30 centimeters. Then find the ratio of length to breadth of the lace. To find the ratio of two quantities, we first need to convert them into the same units. Here, we will represent both the units in centimeters. Since 1 meter is equal to 100 centimeters, 6 meters is equal to 6 into 100 centimeters, which is equal to 600 centimeters. Therefore, the length of the lace is 600 centimeters and the breadth is 30 centimeters. Since both the quantities have the same units, then we can find their ratio. Ratio of length to breadth of the lace is 600 by 30, which is equal to 20 by 1, that is, 20 is to 1. Some students don't pay attention to the fact that their units should be the same. To find the ratio of length to breadth of the lace, they write 6 as the numerator and 30 as the denominator. They write the ratio as 6 is to 30, which is the ratio of meter and centimeter. They further write it in its simplest form, that is 1 is to 5. This ratio shows that the length is 5 times smaller than the breadth. But if we observe carefully, 6 meter length is greater than 30 centimeter breadth. Therefore, writing the ratio of length to breadth as 1 is to 5 is incorrect. Thus, option 1 is incorrect and option 2 is the correct answer. Note that to find the correct ratio, it is very important to keep the units equal. Now let us understand some common mistakes. Some students think that we will know the actual quantity by knowing the ratio of two quantities. Suppose the ratio of toffees with Meena to toffees with Manish is 4 is to 5. Then, students think that Meena has 4 toffees and Manish has 5 toffees. But this is an incorrect understanding. Ratio does not tell us about the exact number of toffees. If Meena has 8 toffees and Manish has 10 toffees, then also we get the same ratio 4:5. Similarly, if the numbers of toffees is 12 and 15 respectively, then again we get the same ratio 4:5. The correct understanding is that the ratio 4:5 does not tell us about the number of toffees. Instead, it tells us the relation between Meena and Manish's toffees. Here, for every 4 toffees of Meena's, Manish has 5 toffees. Today, we have seen some misconceptions and common mistakes related to ratio. Today, we will learn about proportion. Can you tell what is the meaning of proportion? Think for a while. Absolutely correct. We can understand the word proportion as equal ratio. Equal means same. From this, we can derive the meaning of proportion as same ratio. So let's learn about proportion. Here is a picture whose length is 5 inches and width is 7 inches. Suppose we have to make it bigger. In order to make the picture bigger, we can increase its length. Then, the length of the picture will increase but the width will remain the same. By doing so, the picture will not look like the original picture. If we keep the length as it is and increase the width, even then the picture will not look like what it was before. Can you tell how we can increase the size of this picture so that it looks exactly like the original one? Think a while. Let me tell you. If the ratio of the length to the width of the original picture is equal to the ratio of the length to the width of the bigger picture, only then the picture will look like before. Here, the ratio of the length to the width of the original picture is 5:7. If both the length of the picture and the width of the picture is increased by 2 times, then the ratio of the length to the width of the picture will be 10:14. By doing so, the picture will become bigger in size, but it will look exactly the same. Since the numerator and denominator of 5:7 is multiplied by the same number, we can say that 5:7 and 10:14 are equal ratios. If two ratios are equal, then we can say they are in proportion. We use these symbols to denote equality in proportion. Therefore, we can write 5:7 is equal to 10:14 or 5:7 is proportionate to 10:14. Order has great significance in proportion. Here, 5:7 is proportionate to 10:14 because 5/7 is equal to 10/14. We cannot change the order of proportion and write it as 5:7 is proportionate to 14:10. Can you tell the reason for this? Think for a while. Let me tell you. This is because 5/7 is not equal to 14/10. Therefore, the quantities should be expressed in the proper order of proportion. Each quantity expressed in proportion is called term. So the given proportion 5:7 is proportionate to 10:14. 5, 7, 10 and 14 are terms. The first and the last terms among these terms are called extreme terms. For instance, in the given proportion, 5 and 14 are extreme terms. Similarly, the second and the third terms among these terms are called middle terms. For instance, in the given proportion, 7 and 10 are middle terms. Let us understand proportion with another example. Tina and Shelley have made 7 garlands together. They earned ₹35 by selling them. Since Tina has made 4 and Shelley has made 3 garlands, Then how many rupees should Tina and Shelley get? We can divide 35 rupees into two equal parts. Then each part will be 17.5. In this way, Tina can get 17.5 rupees and Shelley can get 17.5 rupees. But will that be correct? Think for a while. You've got it right. This will not be correct. Since Tina has made more garlands, she should get more money than Shelley. This will be correct only when Tina and Shelley get the amount in the same proportion in which they have made garlands. To know the amounts to be distributed to each of them, we need to divide 35 rupees in such a way that the ratio of money received by Tina and Shelley should be equal to the ratio of garlands made by Tina and Shelley respectively. This means out of 35 rupees, 4 parts go to Tina and 3 parts go to Shelley. Therefore, the total number of parts divided is 4 plus 3, which is equal to 7. Thus, in total 35 rupees, 4 by 7 parts belong to Tina and 3 by 7 parts belong to Shelley. So Tina gets her share into total amount, which is equal to 4 by 7 into 35, which is equal to 140 by 7, which is equal to 20 rupees. Similarly, Shelley gets her share into total amount, which is equal to 3 by 7 into 35, which is equal to 105 by 7, which is 15 rupees. Thus, out of 35 rupees, Tina should get 20 rupees and Shelley should get 15 rupees. Only then, 35 rupees can be divided in the ratio of garlands made by them. Hence, the ratio of the amount received by Tina to the amount received by Shelley is 20:15. Are the ratios 4:3 and 20:15 equal? Think a little. Absolutely correct. If we divide the numerator and the denominator of 20:15 by 5, then we get the ratio 4:3. Therefore, we can say that 4:3 and 20:15 are equal ratios. That means they are in proportion. So, we can write the proportion in this way. 4:3 is equal to 20:15, or 4:3 is proportionate to 20:15. Can you give some more examples by looking at your nearby surroundings? Try and do it. Today, we have learnt proportion. In the next video, we will understand it in a better way with some more examples of proportion. Today, we will see some examples of proportion. Maria uses 12 eggs to bake 3 cakes. Sanika uses 40 eggs to bake 10 cakes. Does the ratio of the number of cakes baked by Maria to the number of cakes baked by Sanika and the ratio of the number of eggs used by Maria to the number of eggs used by Sanika make a proportion? Here, the ratio of the number of cakes baked by Maria to the number of cakes baked by Sanika is 3:10. Similarly, the ratio of the number of eggs used by Maria to the number of eggs used by Sanika is 12:40. We can write 12:40 as 12 by 40. If we divide the numerator 12 and the denominator 40 by 4, then we will get the fraction 3 by 10. That is 3:10. As you can see, that the ratio of the number of cakes to the number of cakes and the ratio of the number of eggs to the number of eggs is equal. Therefore, 3:10 and 12:40 make a proportion. We can express the proportion either in this way or in this way. Next example. Prove that 13, 39, 15 and 45 are in proportion. Represent these numbers in proportion and identify the extreme terms and middle terms. 13, 39, 15, and 45 will be in proportion only when the ratio of the first two terms, that is, 13:39, is equal to the ratio of the last two terms, that is, 15:45. So, to prove that 13, 39, 15, and 45 are in proportion, we need to prove that 13:39 is equal to 15:45. We can write 13:39 as 13 by 39, and we can write 15:45 as 15 by 45. Can you tell what we need to do to find out whether two fractions are equal or not? Think for a while. Let me tell you. In order to find this, we will convert both fractions into their simplest forms. In 13 by 39, the HCF of numerator 13 and denominator 39 is 13. If we divide the numerator and denominator of 13 by 39 with the HCF 13, then we get the simplified form of this fraction 1 by 3. Similarly, the HCF of the numerator and denominator of 15 by 45 is 15. If we divide the numerator and denominator of 15 by 45 with the HCF 15, then we get the simplest form of this fraction 1 by 3. The simplest form of both these fractions is equal. Therefore, we can see that 13 by 39 is equal to 15 by 45. That means 13:39 is equal to 15:45, or 13:39 is proportionate to 15:45. Thus, we say that 13, 39, 15, and 45 are in proportion. Out of the four terms of a proportion, the first and last terms are called extreme terms. Among the given terms, 13 and 45 are extreme terms. Similarly, out of the four terms of a proportion, the second and third terms are called middle terms. Among the given terms, 39 and 15 are middle terms. Let us change the order of these terms and see what happens. Suppose we take the order as 39, 13, 15, and 45. Then the ratio of the first two terms will be 39:13, which means 39 by 13. And the ratio of the other two terms, 15:45 or 15 by 45. The HCF of 39 and 13 is 13. After dividing the numerator and denominator of 39 by 13 with 13, we get the simplest form of the fraction 3 by 1. Similarly, HCF of the numerator and the denominator of 15 by 45 is 15. If we divide the numerator and the denominator of 15 by 45 with the HCF 15, we will get the simplest form of the fraction 1 by 3. Here, 3 by 1 is not equal to 1 by 3. Therefore, the two fractions are not equal. Now we can say that 39:13 is not equal to 15:45. Thus, 39, 13, 15, and 45 are not in proportion. If we change the order of the terms and write as 13, 39, 45, and 15, then also these numbers will not be in proportion, because the simplest form of 13 by 39 is 1 by 3, and the simplest form of 45 by 15 is 3 by 1, and 1 by 3 is not equal to 3 by 1. Therefore, we can say that if the order of the terms is changed, it is not necessary that they are in proportion. In the same way, find some examples in your surrounding situations and check whether they are in proportion or not. Today, we have seen examples of proportion. In the next video, we will clear some misconceptions related to it. So far, we have learnt about proportion. Today, we will see some misconceptions related to proportion and the methods to find proportion. Misconception 1. Our 1500 grams is to 3 kg and 300 centimeter is to 6 meter in proportion? Some students misunderstand that the ratios of two different quantities cannot be in proportion. In the given situation, they think that the ratio of weight and distance cannot be in proportion. Similarly, some students simply ignore the units. They simplify the ratios as 1500 is to 3 is equal to 500 is to 1 and 300 is to 6 is equal to 50 is to 1. They think that ratios 1500 is to 3 and 300 is to 6 are not in proportion. Because of these two misconceptions, students choose option 2 as the answer, which is incorrect. The correct understanding is that the ratio of two different quantities can also be in proportion. To express them in ratios, we need to make the units of quantities equal. Since 1 kg is equal to 1000 grams, therefore 1500 grams is to 3 kg is equal to 1500 grams is to 3000 grams. Thus, 1500 grams is to 3 kg is equal to 1 is to 2. Similarly, 1 meter is equal to 100 centimeters. Therefore, 300 centimeters is to 6 meters equal to 300 centimeter is to 600 centimeter. Thus, 300 centimeter is to 6 meters equal to 1 is to 2. Since both the ratios are equal, therefore, we can say that ratios 1500 grams is to 3 kg and 300 centimeter is to 6 meter are in proportion. Hence, the correct answer is option 1. Whenever you want to find out whether two ratios are in proportion or not, then it is necessary to make their units equal. Let us now see how to find whether two ratios are in proportion or not. Suppose we need to check whether 12 is to 15 and 16 is to 20 are in proportion or not. Let us learn some interesting ways to find this out. We have already learnt one method, in which we express both the ratios in fractional form and find their simplest form. To do so, we find the HCF of the numerator and denominator of each fraction. Here, the HCF of 12 and 15 is 3 and the HCF of 16 and 20 is 4. We will divide the numerator and denominator of each fraction with the respective HCF. Dividing the numerator and denominator of 12 by 15 by 3, we get the simplest form of this fraction, that is 4 by 5. Similarly, dividing the numerator and denominator of 16 by 20 by 4, we get 4 by 5. Since the simplest forms of both fractions are equal, we can say that 12 is to 15 is equal to 16 is to 20. That means these two ratios are in proportion. To find out whether these two ratios are in proportion, we make their denominators equal. To do so, we multiply the numerator and denominator of one fraction with the denominator of the other fraction. For instance, if we multiply the numerator and denominator 12 by 15 by 20, we get 240 by 300. Similarly, if we multiply 16 by 20 by 15, we get 240 by 300. Since the fractions are equal in both cases, we can say that 12 is to 15 is equal to 16 is to 20. Among all the methods, cross multiplication is the most interesting method. In this method, we will express the two fractions like this. We will then cross multiply them. That means the numerator of the first fraction is multiplied by the denominator of the second fraction, and the numerator of the second fraction is multiplied by the denominator of the first fraction. 12 into 20 is equal to 15 into 16. The product of 12 into 20 is 240 and 15 into 16 is 240. After multiplication, we get the LHS is equal to the RHS. Therefore, we can say that 12 is to 15 and 16 is to 20 are in proportion. Try this. There are 10 girls and 20 boys in a class. 300 flowers are to be distributed among them. They should be distributed in such a way that the ratio of the flowers given to the girls and the ratio of the flowers given to the boys is 2:1. So find out what the total number of flowers that the boys will get. Today, we have seen misconceptions related to proportion and the methods to find proportion. Today, we will learn about unitary method. Many situations arise in our daily life where we know the value of few things, and with the help of this, we find the value of as many things as we want. In this situation, we apply the unitary method. For example, if we know the value of 1 dozen bananas, then we can find the value of half a dozen, that is 6 bananas, or of more than 1 dozen bananas. The method in which we first find the value of 1 unit and then with the help of this, we find the value of any number of units is called the unitary method. Let us understand this with an example. Raju has fenced his house with 3 full rounds of fencing. It cost him rupees 9,072. If he wants to build a fence with 5 rounds, how much is it going to cost him? Can it be calculated? Think for a while. Let me tell you, the easiest way would be to find the value of 1 round of fence first and then using that value, calculate the value of 5 rounds of fence. Now, the question is how to find the value of 1 round of fence. Think for a while. Let me tell you, total cost of 3 complete rounds of fence is rupees 9,072. Similarly, total cost of 1 complete round of fence is equal to 9,072 divided by 3, which is equal to 3,024. Thus, total cost of 5 complete rounds of fence is equal to 5 into 3,024, which is equal to rupees 15,120. Here, using unitary method, we get the total cost of 5 complete rounds of fence. Remember that if we are given the cost of more than one object, then dividing the cost with the number of objects would result in the cost of one object. Then, the outcome is multiplied with the number of objects to get the cost of as many objects as wanted. Let us understand it with some more examples. When you go to a shop, the shopkeeper tells you the cost of an object. On the basis of this, depending on how many objects you want to buy, you can find out the cost of the total number of objects. Here, you are using the unitary method. When you go to buy vegetables, the shopkeeper tells you the cost of 1 kg of vegetables. On the basis of this, you find the cost of 250 grams, half a kg, 1.5 kgs, and 2 kgs or as much as you want. Here also, you use the unitary method. Similarly, for the following situations also, you will use the unitary method. Drivers find out the mileage of their vehicle based on distance traveled in 1 liter of petrol. Based on this, they find out the amount of petrol that is required to cover the desired distance. Depending on the number of units a company makes in one day, one can calculate the total number of its produce in a month or a year. Try to recall 5 such situations where you would use the unitary method. Today, we have learned about unitary method. In the next video, we will learn about it with some more examples. Today, we will see some examples of unitary method. Example 1. Rahul's group wanted 6 similar shirts for a dance competition. He bought 6 shirts for 245 rupees each. Find the amount that he has to pay for 6 shirts. Here, we have to find the amount Rahul has to pay for 6 shirts. We are given the cost price of 1 shirt, that is rupees 245. In order to find the cost of 6 shirts, we have to multiply the number of shirts, that is 6, with the cost of one shirt, rupees 245. Therefore, cost of 6 shirts is equal to rupees 245 into 6, which is equal to rupees 1470. Next example. If the cost of 4 dozens of mangoes is rupees 120, then find the cost of 20 mangoes. From the given example, it is clear that the cost of 4 dozens of mangoes is rupees 120. Since 1 dozen is equal to 12 items, therefore 1 dozen is equal to 12 mangoes. Similarly, 4 dozen mangoes is equal to 12 into 4, which is equal to 48 mangoes. Thus, we can say that the cost of 48 mangoes is rupees 120. Now, how do we find the cost of one mango? Think for a while. You've got it right. To find the cost of one mango, we have to divide rupees 120 by 48. Cost of one mango is equal to rupees 120 divided by 48. Since we need to find the cost price of 20 mangoes, we multiply 20 with the cost of one mango. Therefore, cost of 20 mangoes is equal to 20 into 120 by 48. By solving this, we get the cost price of 20 mangoes, that is rupees 50. In this way, we can solve such questions easily with the correct use of unitary method. Example 3. For covering a distance of 180 kilometers, a vehicle requires 4.5 liters of petrol. Find out how much petrol is needed by a car to cover a distance of 800 kilometers. Also, how much distance will this car cover using 10 liters of petrol? First, let's find out how much petrol is needed to cover a distance of 800 kilometers. Required petrol for covering a distance of 180 kilometers is equal to 4.5 liters. Here, we convert the mixed fraction 4.5 into an improper fraction and get 9 by 2. Therefore, required petrol for covering a distance of 180 kilometers is 9 by 2 liters. Thus, required petrol for covering a distance of 1 kilometer is equal to 9 by 2 divided by 180, or we can write it as 9 by 2 divided by 180 by 1. To divide fractions, we keep the first fraction as it is and then multiply it with the reciprocal of the second fraction, 180, which is 1 by 180. Therefore, petrol required for covering a distance of 1 kilometer is equal to 9 by 2 into 1 by 180, which is equal to 1 by 40 liters. Thus, petrol required to cover a distance of 800 kilometers is equal to 1 by 40 into 800, which is equal to 800 by 40, which is equal to 20 liters. This means the vehicle must have 20 liters of petrol in it. Let's find out how much distance this vehicle will cover in 10 liters of petrol. As we can see, the vehicle will cover 1 kilometer distance in 1 by 40 liters of petrol. If we multiply both sides by 40, then we get to know that the vehicle will cover 40 kilometers distance in 1 liter of petrol. Similarly, the vehicle will cover 10 into 40 kilometers, that is 400 kilometers in 10 liters of petrol. Today, we have seen some examples of unitary method. In the next video, we will learn some misconceptions related to this. Today, we will see some misconceptions and an interesting question related to unitary method. Misconception 1. A car covers a distance of 50 kilometers in 2 hours. Find out the distance that it will cover in 6 minutes. Many a times, students do not focus on units. They just consider the numbers and perform mathematical operations to get the answer. They simply divide 50 by 2 and get the result as 25. Then they observe that the next number is 6 and multiply 25 with 6 to get the result, that is 150. This leads to an incorrect answer and they give option 1. To solve any question, it is a must to consider its units. Here, the distance covered by a car in 2 hours is equal to 50 kilometers. Thus, the distance covered by a car in 1 hour is 50 divided by 2, which is equal to 25 kilometers. Since 60 minutes is equal to 1 hour, therefore, 1 minute is equal to 1 by 60 hours. Similarly, 6 minutes is equal to 1 by 60 into 6, which is equal to 1 by 10 hours. The distance covered by a car in 6 minutes is equal to 1 by 10 into 25, which is equal to 25 by 10, which is equal to 2.5 kilometers. This results in the correct answer, which is option 2. Let's solve an interesting question. A worker takes 13 days leave in the month of March. Due to this, he gets rupees 5,670 as salary at the end of the month. If he does not take any leave in the month of April, then how much salary will he get? This is an interesting question. Let's solve it. In the example, it is given that the worker takes 13 days leave in the month of March. Due to this, he gets rupees 5,670 as salary. Can you tell how we will find out his salary per day? Think for a while. Let me tell you. Here, it will be incorrect to divide 5,670 by 13 because the salary is given according to his working days. The salary of 13 days is deducted because he is on leave. Can you tell how many days he will be paid for? Think about it. You have got it right. There are 31 days in the month of March. Out of these, he has not worked for 13 days. Therefore, at the end of the month, the worker will be paid for 31 minus 13, which is equal to 18 days only. Since salary of 18 days is equal to rupees 5,670, salary of 1 day is equal to rupees 5,670 divided by 18, which is equal to rupees 315. Since we know the salary of the worker per day, we find the salary of April. There are 30 days in the month of April. Thus, April's salary is equal to 30 into 315, which is equal to rupees 9,450. That means the worker does not take any holiday in April. He will get a salary of rupees 9,450. Today, we have seen some misconceptions and an interesting question related to unitary method.